ever jumped on your bed hard, and what did you notice? Today, we will be learning about a force that made your bed squish, called compression force. In this lesson, we'll explore what compression force is, how it works, and some fun examples of compression force in action. So, what is compression force? Compression force is the push or squeeze that happens when we apply pressure to an object. When we push down on something, it gets squished together. Compression force is all around us. Here are some examples of compression force. Squishing a sponge. When you press down on a sponge, it gets smaller and squishier. That's because you're applying compression force to it. Sitting on a cushion. When you sit on a cushion, it gets flattened under your weight. And that's compression force at work. Squeezing Play-Doh. When you squeeze Play-Doh in your hands, it gets compacted into a smaller shape. That's compression force in action. Jumping on a trampoline. When you jump on a trampoline, the springs underneath compress as they push back against your weight. That's compression force helping you bounce. Let's do a simple activity to show compression. For this activity, you'll need a sponge and a marker. So with a permanent marker, you're going to draw a series of lines that go from the top to the bottom of your kitchen sponge. So I'm going to start with one in the middle, and then I'm going to put two more lines on each side and just divide them equally. There we go. Your sponge should look something like this. Now we're going to connect them on the back side of our sponge also. Now we should have lines on both sides of our sponge. So next, what we're going to do is bend our sponge into a U shape. And we'll observe what happens to each of our sets of lines. Let's go ahead and bend it. Now, if you notice, the lines that are on the inside of the U get closer together. But the lines that are on the outside of the U get further apart. So what's happening? Where is the sponge in compression? Well, the sponge is in compression on the inside of the sponge, where the lines are getting closer together. On the outside of the sponge is tension, which we're not going to talk about that force today, just the compression. So you might be asking, why do I need to learn about compression? Well, these days, the most popular materials used to build bridges are steel and concrete. Other materials can be used, but the reason why steel and concrete are so popular is because of their ability to withstand internal forces, or compression forces that are pushing forces, and also tension, or pulling forces. If we build using materials that are weak against these forces, our structure might be at risk of collapsing, making it dangerous for humans to use. Now, it's important for engineers to test and measure the strength of their materials so that they can properly design and build structures that can withstand the forces that will affect them. In the next activity, we'll be testing the strength of clay or Play-Doh against compression forces. For this activity, you're going to take some books, a ruler, and clay or Play-Doh. To start, we're going to make a rectangle with our Play-Doh. We're going to measure it out so that it's 2.5 centimeters by 2.5 centimeters by 7.6 centimeters. Now, I'm going to put my dough on a flat surface like my table so that it's standing like it's a tall tower. Now, my tower is 7.6 centimeters. Okay, so we're going to take our first book and set it on top, and then we're going to measure the height. So mine is about 7 centimeters right now. Now I'm going to take a second book and set that on top, and it knocked over my tower completely. So it knocked over my tower, but you can see where it has compressed. So let's measure that compression. So right there, I've got 5.5 centimeters. So we went from 7.6 centimeters all the way down to 5.5 centimeters with just 2 books. And let's see what happens when I put 3 books on top. Let's see if it can hold that. All right, so it is holding that. And now we're gonna measure the height. And that is 3.5 centimeters. So you can see that with each book, I'm adding weight and compressing my clay dough more and more. Look at how flat that is now. Here's what we observed. As the books were added, we increased the compression force of the tower. Eventually, the dough couldn't support the load and began compressing. The force on top of the clay created strain or stress on the material. This is similar to what happens if a bridge or a building is trying to support a load that is too heavy for the material's strength. It will break or collapse. Since compression force is critical to the stability of building structures, let's build a structure right here and get a better understanding of how it works. Well, we can't construct a building. We can mimic that by using toothpicks and marshmallows. For this activity, all you're going to use are some little marshmallows and the toothpicks. Now, this is easier if you allow your marshmallows to dry out for a day or two before you start. So to make sure that they're not too mushy, spread them out on a flat surface such as a tray, plate, or a cardboard box. Next, we're going to start creating our skyscraper's base. I'm going to start with 4 marshmallows and 4 toothpicks. I'm going to connect these together. Now I want this to be extra strong, so I think I'm going to go ahead and add another toothpick to go across. So there's my base. Now I'm going to make another layer just like that. And I'm going to go ahead and put these in and then connect the 2 together. Now I want to give it extra strength, so I'm going to put in a couple more diagonal toothpicks. All right, now I'm going to go ahead and do the same thing again. So what's happening as I'm adding more layers to my tower is that more compression force is being put on these marshmallows, which is making them squish together and deform so that they bear the weight of the tower above them. You can break apart the spaghetti to make support lines like triangles across. So mine doesn't have that right now, so it's a little unstable, but you can still see that the point of this is the higher you build, the more the compression force is on the marshmallows. In our toothpick marshmallow tower activity, compression force plays an important role in ensuring the stability and strength of the tower. The marshmallows serve as the connecting points between the toothpicks. As more marshmallows and toothpicks are added to the tower, compression force causes the marshmallows to squish and deform slightly as they bear the weight of the tower above them. Today, we learned about compression force. Compression force is an interesting concept that helps us understand how things change shape when we push or press on them. It is the push or the squeeze that happens when we apply pressure to an object. Compression force is all around us, at work or at play, or even in the construction of buildings. I hope you had as much fun learning about compression force as I did. See you next time!